In order to demonstrate the global mesh settings inside Ansys Workbench, I have opened Ansys Workbench. Right now I'm going to just go to the component systems and drag and drop this mesh component system onto the project schematic, because here we are not going to apply the boundary conditions and we are not going to solve the problem. So I'm going to take just mesh system here, and once I take the mesh system, I need to right click on the geometry cell and go to import geometry, and I need to browse. And once I browse, I need to go to this location where I have this particular file. So here I found the geometry that I need to mesh. Then I have opened it, and once I open, I can just double click on this mesh cell so that Ansys Mechanical will open with the mesher on. Ansys Mechanical will open, and once Ansys Mechanical opens with the geometry, then we are going to apply some global mesh controls, and we are going to see what are those global mesh controls. So coming here, see, here is a body with some straight faces, straight edges, as well as circular edges with holes and other sorts of things. So as I told you, we have automatic mesher that is inbuilt into Ansys Mechanical, which is very efficient in generating meshes, initial meshes. For example, if the body is very simple, the automatic mesher is going to very accurately generate the mesh. But if the complexity of this particular geometry is going to increase, this particular mesher can be used to create an initial mesh, and from that initial mesh we are going to use some localized controls to generate more efficient mesh. For now, what are we going to do is we are going to go to this mesh group. Once we go to the mesh group, see here, the first and foremost option is known as the physics preference option. So based upon the type of analysis you are going to perform, this particular automatic mesher inside Ansys Mechanical will change the settings. For example, I have set the physics preference to mechanical. What I am going to do is I am going to just right click, say generate mesh. So once I generate the mesh, now what I am going to do is I am going to go to the statistics, and see here in the statistics the number of nodes that are generated are 7130, right? So now what I am going to do is I am going to go to the physics settings, and instead of mechanical I am going to select CFD. So what happens in CFD, we need more finer meshes. So what happens, the automatic mesher will be increasing the mesh density. So I am going to right click, say generate. So now once I have generated the mesh with this CFD physics preference, see what happens. The number of nodes has increased to 40,669. So what happens, we definitely have an effect of this global setting, which is nothing but physics preference. Likewise, you can also select the type of solver. Generally, you have 2 to 3 different types of solvers inside Ansys Workbench for performing CFD. So what happens, you have Fluent solver, you have CFX solver, you have Polyflow solver. So you can also select the settings from here as well. So I'm going to just go back to mechanical, and I'm going to just remesh this particular object by just right clicking and say generate mesh. So the next option we are going to see is the relevance option. So relevance is nothing but you will be having a setting where you can control it from -100 to +100. So what happens if you set the relevance to -100, say, which is the minimum value, then what happens when you try to generate the mesh with some settings, it is the coarsest mesh that you are going to get with those specific settings. So I have selected the physics preference to mechanical. So I'm going to just keep the relevance to 0. Then I'm going to generate the mesh once again. See, I'm going to generate the mesh once again. And once I generate the mesh, you can see the number of nodes are 7130. Okay. Then what I'm going to do is I'm going to set up the relevance setting to -100. So what happens, this particular number of nodes and elements should be decreasing, because what happens, -100 is the minimum relevance value. So I'm going to just type in -100 and I'm going to press OK. Then I'm going to just generate. So once I generate the mesh, you can clearly see from this picture as well, the mesh density has decreased. See here, the number of nodes have changed from 7130 to 2349. So what can I do? If I just set the relevance setting to +100, so if I take it to +100, see, if I take it to +100, what should happen? it should increase the mesh density. So I'm going to just right click on this and say generate mesh. So instead of 7130, I should be getting more number of nodes. So see here, the mesh density has clearly increased and the nodes, number of nodes have increased to 21,515. So what happens with the relevance setting? So in the automated mesher, you have some default settings. Based upon that default settings, if you are going to put up the value of relevance to -100, this is the coarsest mesh you are going to generate with these settings. But if you are putting it to +100 with the specific settings, you are going to generate the finest mesh. This is one setting. Then coming to next one, you can go to the sizing group. In the sizing group, you have what is known as a relevance center. In the relevance center, you again have three settings. One is the coarse, other one is the medium, and other one is the fine. If you want to generate the coarse mesh, you are going to put up coarse. And in the coarse also, if you put relevance 100, this is the minimum coarse mesh that you can generate with these settings. So for example, if I change it to fine rather than coarse, so what happens, see here, the number of nodes must be increasing because the mesh density is going to increase, because previously we have generated the mesh with coarse settings. Now what I'm going to do is I'm going to just right click, say generate. So once I say generate, see the number of nodes will be increasing from 21,000, and I think the relevance is 100, so it will be increasing multiple times. If we are going to change it from coarse to fine, what happens? See, the mesh density has increased tremendously, and see, instead of say 21,000, the number of nodes were around 2,38,000. So this is how you can change different settings. If you want a coarse mesh, you can just go back and say coarse, and you can regenerate the mesh. Then coming to the next option is nothing but the element size. So element size means you can give a default element size, and based upon that element size, the automatic mesher is going to generate a mesh. For example, if you have a 10-meter bar and you give the element edge length as 0.5 meter, then what happens? The mesher is going to generate a mesh of 20 elements, each of 0.5 meters. Likewise, if you give the element size, it is going to generate. For example, we are going to see here, I'm going to go back to the coarse mesh and I'm going to just generate the mesh. And once I regenerate the mesh, right now what I'm going to do is, okay, I will also reduce this relevance to 0 so that I can get a coarse mesh for this purpose, for demonstrating purpose. Then coming to the next option, we have what is known as the size function, and based upon this size function, we get more control over the global mesh settings. For example, let us say if we have selected this curvature setting, what happens is at the curvatures, if the body is having lot of curvatures, at this particular curvatures, you will be getting more finer mesh, or you will be getting more structured mesh. And if you select the proximity, see for example here I'm going to select the proximity, and see here I'm going to show you. So at this particular edge, this particular circle and the edge are very much nearer to each other. So what happens in the default settings, I don't have any refined mesh here, but if I select the proximity and generate the mesh, see here, without increasing the mesh density here, it has increased the mesh density here where there is two features in proximity. Likewise, if you have curvature, if you put the curvature setting, you are going to get more finer mesh on the curves. This particular proximity feature will be helpful when there are lot of features very nearer to each other, and if you have lot of curvatures on a body, you can use the curvature option, or otherwise you can add proximity and curvature so that both of the settings can be applied to this particular body at the same time. And coming to the next option, which is nothing but the uniform option. So what happens is you are going to give the element sizes, and based upon the maximum and minimum element size, it is going to generate the mesh. These are some of the global mesh settings you need to be knowing in order to create efficient mesh for your simulations. In the next lecture, we are going to see some of the local mesh controls which are pretty useful for us to generate efficient mesh inside Ansys Workbench.